Bismillahirrahmanirrahim. In today's class, we'll be discussing about concentration, what it is, and how can we actually understand it. So, concentration is the amount of solute dissolved in a specific volume of solvent. What exactly is a solute and what exactly is a solvent is written right there. A substance dissolved in another is a solute. A good example of that is NaCl or table salt. A solvent is a substance in which the solute dissolves. So if you take water and NaCl and combine them together, NaCl is behaving as a solute and the solvent is water. And usually speaking in chemistry, the solvent is water because chemistry and chemical reactions, a lot of the chemical reactions happen in water and have water behaving as a solvent in them. So that's why we have a special way of representing uh, state of matter in which a substance is dissolved, and that is aqueous. So AQ, if it is written anyway, then that means that it is talking about, so basically if there is something like this written, then it is talking about a substance that is dissolved. So for example, if I want to write NaCl dissolved in water, I won't write it in a very long way. I can just write it as NaCl bracket aqueous, just like we used to write it as solid, just like we can write it as liquid, we can write it as aqueous. That basically represents that it is dissolved in water. Now when this happens, when this type of substance happens, when you dissolve a solid into a solvent, it creates a solution, and when the solution is formed, it will have a concentration. So as I said, recalling it again, it is the amount of solute dissolved in a specific volume of solvent. Now, of course, the solvent is a liquid part, so we will be measuring it in terms of the volume and not in terms of any other way. The amount of solute, now that can be made in two ways. It can be made in grams and it can also be made in moles. We can do it either way. We have studied in the previous lectures how we can convert from grams into moles. As long as we know what substance we are talking about, we can convert it back and forth without any problems. All right, so let's see this in action. So we have this diagram right here, and this diagram is basically showing us exactly that, right? So a solute or NaCl represented by the red dot and solvent represented by the blue dots are shown right there. So you can see that NaCl is dissolved in this particle in this solution, and it is spread out along the water. And if I were to calculate the concentration of sodium chloride in this solution, I would do it by using this formula right here. Concentration is calculated in molar or m. It is just a way of representing concentration. So you can write concentration in terms of formula as concentration is equals to the amount of solute, again the same thing that was written before, and divided by the amount of solvent. A better way to write it is by writing it as the volume of solvent. So we should write it as the volume of solvent made in volumes, and that can be in decimeter cube, that can be in meter cube. Usually speaking, it is in decimeter cube, so you need to keep that in mind. And that in terms of SI unit will be represented by mole per decimeter cube, or again mole per meter cube per centimeter cube. It depends, it can vary. As long as it is a volume that is being divided to moles, it is talking about concentration. Another way to represent it is by writing m. What m represents is mole per decimeter cube or molar. All right, so let's start to understand this concept a lot better. So effects of each, what do I mean by effects of each? I mean that what exactly, in terms of the amount of solute and in terms of the amount or the volume of solvent, how does this affect the concentration? So by looking at the formula, a lot of students can actually understand what it means and what changing these things would mean. So instead of doing that, instead of going into proportionality and all of that stuff, we can understand it by using some simple calculations. So let's get on to that. So for example, I have a situation in which affects of each, right? So I have a situation in which 1 mole of NaCl is dissolved in 1 decimeter cube. If I were to calculate the concentration right here, let me just use a much thinner pen, then the concentration will be 1 mole divided by 1 decimeter cube, and that will give me 1 m or 1 molar, right? Now let's vary that. All right, this was my constant. This gave me an understanding that, hey, if I take one thing and I make it basically a substance in which there's a consistency, right, and if I change that consistency, how will that affect the concentration? So let's do that. Let's change the solute or the amount of solid that we had in the previous situation. Let's change that and let's see how does it affect. Keep in mind that when we are changing something, we will keep everything else constant. So if I'm changing the amount of solute, this is the amount of solute, then you can see here that the amount of dissolved water is the same, or the amount of water it is dissolved in is the same. The amount of volume is the same. 1 decimeter cube, 1 decimeter cube, that is consistently the same. The only thing that I am changing is the amount of NaCl. Let's calculate the concentration. Once again, it will be concentration is equals to, it will be 2 moles this time upon 1 dm3, and this gives us 2m. So you can say that increasing the amount of moles when you have a constant volume will increase the concentration. Another way and a better way to understand it is by thinking about it in terms of proportionality. So I can say that concentration is directly proportional to the moles of solvent. As you can see here from this understanding and changing these values. Now let's do the opposite. Let's change the solvent instead of the solute. So we can come back here and let's take a look at this. So we have the solvent, right? We have this situation in which we are changing the solvent and the amount of solvent. And keep in mind again that if I'm changing one thing, and that is the solvent, so I'm making sure that my other thing was constant. So these two values are constant. So I'm taking the same amount of moles as I had taken for my test value, or the value that I'm measuring against, right? So if I were to use the formula again, it will give me 1 mole upon 2 decimeter cube, or this will give me 0.5 m. Now this is the interesting thing. Now you can see that increasing the volume while keeping the amount of moles constant, what happens is that your concentration is decreasing. We can see it in diagrammatic form as well. So we can say that concentration is equals to, or it is directly proportional, or inversely proportional to be exact. It is inversely proportional to the amount of volume of solvent. So if you increase the volume just like I did here, you can see that the concentration is decreasing, right? If I were to increase the moles of solvent or increase the moles of solute properly, my concentration will increase as well. Let's see in diagram, and when we understand it in diagram, it will be a lot more beneficial as well. So here I have the same situation as I had made previously. Okay, this is the same situation, and here you can see that there is more amount of NaCl than H2O. There's a lot more, right? That is what shows an increase in concentration. That is an increase in concentration. That is more concentration than the previous situation or the previous standard that we had. If I were to go and look at this situation, you can see something that has changed, and the thing that has changed is the amount of volume. I have increased the amount of volume of water. There's more water here, and that's why the sodium chloride or the solute is more spread out. There is less mole of sodium chloride per volume of H2O. So you can think of it in terms of a different way. So let's think of it in a much easier way. So for example, I take this portion right here and I declare it as, hey, this is 1 decimeter cube. Now, of course, if this was 1 decimeter cube, then it would be a lot smaller. But for example, this is 1 decimeter cube. Then you can count the particles here. You can count that, hey, there are 3 particles of NaCl. So this is showing a very good amount of concentration. There is a lot of NaCl per decimeter cube of water. Here, if I were to figure out the same amount of volume or 1 decimeter cube, then perhaps this is the amount, and you can see that there is 1 particle of NaCl. So there is less amount of NaCl per decimeter cube. 1 decimeter cube this, 1 decimeter cube that. The difference is that there is more particles of NaCl per decimeter cube and there is less particles per decimeter cube in here. That's the reason why you are capable of calculating it in terms of that formula. So that formula can be imagined in terms of other ways as well. So if you have studied density, then density is equals to the mass per volume, right? This is what and how you represent density. So what exactly is density? Well, the density is the concentration of mass. Exactly, that's what it is. It is the concentration of mass. So if you have a piece, so for example, you have a piece of steel, right? And you have 1 kilogram of steel, and you have a bag that has 1 kilogram of feathers. If I were to ask which thing is heavier, then you will say that, hey, steel is heavier. But this is a commentary. This is actually like a puzzle. I've seen it a lot on the internet, and here as well, that is not the case. Both are 1 kilogram. The mass is the same. The difference is the density of steel is more. There is more mass. There is more mass per volume. On the feathers, there is less mass per volume. That's why you need a lot of volume of feathers. You need a bunch of feathers so that you can equate the same amount of mass. You need a small piece of steel so that it is 1 kilogram. You need a large amount of feathers so that it is 1 kilogram. The difference is due to densities. Feather is extremely less dense than steel, and that's the difference here. So you can understand, if you have an understanding of density, then you can understand concentration in terms of that as well. Density is basically the concentration of mass of a substance. As you can see, if I were to bring up the concentration and densities formula, then the only difference is the mass. Over there we are talking about the amount, or in terms of moles, or the quantity, and over here we're talking about the mass, right? We're talking about the mass. So I've said that you can measure the amount of concentration in terms of both moles or grams. The examiner can give you in terms of both, so it is possible for you to get either or. And if you get it in terms of grams, there is no problem. You can convert it into mr or moles very easily. How? Just recall what the formula of moles was. Moles was equals to the mass upon the mr, or the atomic mass, or the molecular mass. So if you have mass, right? If you have mass, for example, I have a solution in which 1 gram of NaCl is dissolved in, let's say, 10 decimeter cube. All right, and the examiner asks a very simple question, that write it in terms of mole per decimeter cube. So how will I do that? I will just figure out the mass. Well, I know the mass, I'll just figure out the moles, right? I'll just figure out the moles. So how do we do that? Well, You can get moles by dividing the mass with the MR. So let's just do that. If we find the concentration as 1 gram upon 10 decimeter cubed, and we want it in terms of moles, then perhaps I can just divide this thing with the MR of NaCl. And when you do that, it will give it to you in terms of the moles of NaCl instead of the gram. I just use the formula. I just use the fact that the moles is equals to the mass upon the MR, and that's how I got it in terms of moles per decimeter cube. Right? So you can do that easily and you can get the answer. Furthermore, we'll be doing a lot more questions of this, and it will be a lot more interesting because this chapter plays a hand to hand understanding with a lot of other chapters and a lot of other understandings as well, in terms of biology, in terms of chemistry, in terms of physics as well. So you need to have a good grip on this and how it works and what exactly it is talking about. So I hope you understood what exactly I was saying here, and I hope this was helpful or insightful and gave you a very better perspective about what concentration is. So if you did enjoy, and if this was helpful, then feel free to share it with others as well. Perhaps it will be helpful to others as well. So see you in the next class. Very Allah Hafiz.